welcome back to Spring into Math 7. I'm Mrs. Campbell. We're going to continue in our series now on theoretical probability by talking about unequal probabilities. Let's jump in. So the steps below show how the theoretical probability is found using a spinner with 2 yellow, 2 gray, and 1 pink section. Remember that all of these are fair. That means that the amounts in each section are equal. So we're just going to jump right in with an example. So how would we do this? Well, step 1 is we would count the number of favorable outcomes. There's 2 yellow spaces, so favorable outcomes would be 2. Step 2, count the number of total outcomes. There are 5 spaces in all, so total outcomes equals 5. And then step 3 is to write the ratio of favorable outcomes to total outcomes, and that would be 2 to 5. Not so hard, right? Let's look at another example. It says, list the sample space for rolling a die. What is the theoretical probability of rolling a prime number? Remember, a die is a 6-sided figure with dots representing the numbers 1 through 6. Simple. So the sample space is all the possible outcomes, so all the numbers that could possibly be rolled. We know that the sample space is 1 through 6. 1, 2, 3, 4, 5, 6. So there's 6 possible outcomes. Now let's talk about the possibility of the number being prime. Well, there's 3 ways to get success with a prime number, 2, 3, 5. So now we need to find the theoretical probability by using the equation, which is the probability of success is the number of ways to get success over the total number of possible outcomes. So for this example with the die, we want to remember there's 6 possible outcomes. There's 3 ways to get success. So the probability of success using this ratio, the number of ways to get success over the total number of possible outcomes, is 3 out of 6. So the probability of success for us is 1/2 once we simplify it. That means that theoretically, 1 out of every 2 times a die is rolled, a prime number will come up. When rolling 2 dice, the sample space gets much bigger. So much bigger that it's easier to see actually in a chart. So here's a chart that shows all the possible combinations of rolling 2 dice. The sample space below has a total number of 36 possible outcomes. So we can use this table to look at the theoretical probability of rolling certain combinations of numbers on the dice. If you want, take a minute and pause your video and take a look at that. You'll see the pattern. Interestingly, if you draw diagonals, you can actually find the sum of different rolls. And it would seem from the table that rolling a total of 7 has the highest probability of happening. So that's because there's 6 different ways of rolling a 7. You've got 6 and 1, 5 and 2, 4 and 3, 3 and 4, 2 and 5, and 1 and 6. Here's a question for you. How many ways are there to roll a 2? Well, there's only one way, and that's 1 and 1. So that's not very likely, is it? That has a lower probability. So do you see the pattern in this table? Ways to roll a 2, 1. Ways to roll a 3, 2. Ways to roll a 4, 3, and so on and so forth. Last example. Let's suppose that the numbers 0 through 9 were each written on a piece of paper and placed in a bag. If one of the pieces of paper were chosen at random, what is the theoretical probability that it would be an even number? If this experiment were repeated 10 times and an even number were chosen 8 times, what would be the experimental probability of choosing an even number? Okay, so our sample space is 0 through 9. So there's 10 possible outcomes. There are 5 even numbers, 0, 2, 4, and 6. Those are our favorable outcomes or our successes. So next, we're going to use the ratio to find the theoretical probability that the piece of paper drawn is an even number. Remember, our sample space is 0 through 9. There are 5 even numbers, 0, 2, 4, and 6. So here's our ratio. We have the probability of success equals, again, remember, the number of ways to get success over the total number of possible outcomes. So the probability of it being an even number, 5 out of 10. When we simplify it, the probability of it being an even number are 1 out of 2. So there it says in blue, the theoretical probability of picking an even number is 1 to 2. All right, everyone, that does it for this lesson. Thanks for joining us. We'll see you next time. Bye-bye.